All right, hello students. I hope that you are sitting back in your recliner, having some coffee or hot chocolate or something delicious, and watching these notes from the comfort of your own home. Yes, what we're learning here on your off-campus learning day is section 2.6. We're looking at how can you look at a function and know right away what the position of the function will be on your xy coordinate plane. Meaning, will it be in the first quadrant, second, third, or fourth? Okay, to help you think about this, I'm going to refer back to the notes of 2.5. Specifically, what you did on the back of this page. You've already learned this. If you have a basic function, we call that the parent function. That's the function in its most basic form. It will be flipped upside down if there's a negative outside of the function. It will be shifted to the right if it's inside of the function. And what I think is if a number is inside math markings, it's the opposite of what you see. So this -4, I would think left 4. That's the way my mind works. I think negative left. But if it's inside markings, that means right 4. +4, it's inside markings, so that means it's going to go left 4. And then outside of your function or of those markings is exactly what you see. -2 means down 2, +2 means up 2. So what we've looked at in 2.6 is we're just describing what you see. Vertical changes up and down are seen outside of your markings. So if it's +k, it goes up k units, -k is down k units. Numbers inside of the absolute value are opposite of what you see. It's going to, if it's plus a value inside, that means left that many units. And if it's minus a value, it moves to right that many units. And then if you have a negative outside the absolute value, that's going to flip it over the x-axis. The only new piece here that you might not have heard too much in your past is called the parent function. The parent function is the original or most basic graph. Let me give you an example. If you're looking at the absolute value parent function, that means you're looking at nothing added, subtracted, or multiplied to the function. For example, if I give you this function, y equals the absolute value of x minus 1 plus 3, the parent function would just be y equals the absolute value of x. It's the parent, it's the most basic, it's where the function came from, potentially. You can think your parents are where you came from, so in the same way, you're looking at the most basic form of the function. If I looked at a linear function, here's another example. If I had y equals 2x plus 1, the parent function for that, parent function, would just be y equals x. And we'll have more practice with that on the next page. But let's try example 1. It says graph this function and graph the next function on the same coordinate plane. Describe how the graphs are related. Make a table of values and graph the equation. So let's start. Let's say we didn't know what we learned above, and let's just make a table. Let's graph this one first. Y equals the absolute value of 2x. We know it's going to be a V shape from the absolute value. We know that we have to start at the vertex. So the vertex, we take what's inside the absolute value, set it equal to 0, and solve for x. That gives us x equals 0. And then our y-coordinate comes from what's been added or subtracted outside of the function, which is just a +0 here. So it's 0, 0. And I graph that. And I plot my vertex as 0, 0. And then I need just 2 other points in my table. So I have x and I have y. I'm going to choose a point to the left of my x-coordinate in the vertex. So the left of 0 would be like -1. Plug that in. In my function, 2 times -1 is -2, but the absolute value of -2 is 2. So I have the point -1, 2. And if I plug in a point to the, or I can reflect that to the point 1, 2. And if I plug in one more point to the right, I might want to plug in 2 for x. The absolute value of 2 times 2 is the absolute value of 4, which is 4. And I plot the point 2, 1, 2, 3, 4. That's 2 to the right, so I'm going to reflect that point 2 to the left. And now I have this function, y equals the absolute value of 2x. It's not the parent graph because I have a 2 multiplied inside, but it's close to the parent graph. The parent graph would be y equals the absolute value of x. What this 2 did to it is it just narrowed the shape. Or some people like to think of one side of the absolute value as having a slope of 2 over 1, up to right 1. Okay, but now we want to take a look at graphing y, I'll put this in a different color, y equals the absolute value of 2x plus 3. We want to see, well, how can we use this, what we've done before, and see how this graph will change? Well, hopefully you're thinking to yourself, the plus 3 moves the graph up 3 units. So the vertex is no longer at 0, 0, it goes up to 1, 2, 3. Now it's at the point 0, 3. And if I did a table, x, y, so I didn't have to do the algebra work here, I just know that's my vertex from the shift that I see in the function. All of these points, I'm going to add 3 to the y because every point goes up 3 units. So if I have -1, I could plug it into the function or just see that it's going to be the 2 plus 3. So I'm going to have -1 up 1, 2, 3, 4, 5. Every point goes up 1, 2, 3 units. This point 2 is going to be 2, 4 plus 3. So it's now at 2, 7. 2 up 1, 2, 3, 4, 5, 6, 7. So I could reflect these points. Now I have my graph, and it was easier to create because I understand how the shifts work. All right, let's move to the next page, and I know this got copied kind of funny. We've already done this. We're actually moving 2 pages over to the back of 2.6. Okay, let's go back to our what we know about linear functions. It says identify the parent function for y equals x minus 4 and the value of k. Means what's your shift? Then graph the function by moving, that's another word for translating, by moving the parent function. So what's the parent function? We already referred to this in the first page. If you have a linear function, the parent function is just y equals x. So let's graph that parent function. Well, if y equals x, some of you might know it's a diagonal line through the origin. If you didn't know that, just plug in values for x and y. 0, 0. When x is 1, y is 1, so I have 1, 1. When x is 2, y is 2, so 2, 2. When x is -1, y is -1. So here's my parent function y equals x. And you can see it. X is 2, y is 2. X is 1, y is 1. X is 0, y is 0. Y equals x. Okay, so we graph that. What's the value of k, your shift? Well, k, the shift, is 4. Specifically, it's down 4 units. It's -4. We're going down 4 units. Notice there's no absolute value, so we don't have a left or a right change here, but every point is going to go down 4. So 0, 0 is now going to become 0, 1, 2, 3, 0, -4. 1, 1, I'm going to subtract 1 from the y value, and becomes down 1, 2, 3, 4, becomes 1, -3. 2, 2, I'm going to subtract 4 from the y value, and it becomes 2, -2. So we graphed that function just by using what we know about translations, about shifts. So it's at negative, every point moves down 4 units. All right, example 3. Write an equation to translate, move the graph of y equals absolute value of 4x 5 units down. Well, if we're going down, we know that that's going to be outside of the absolute value. So that's y equals absolute value of 4x minus 5. And that's it. We box it. Example 4. Identify the parent function and the value of h, your shift. Graph both functions, list the domain and range of each. here's our function. What would be the parent function? Well, the parent function is the most basic form of the function, y equals absolute value of x. It says graph both functions, so if I'm going to graph this, I know that the origin is there, 0, 0. You can think of having a slope of 1 on each side because it's the parent function, or you could plug in numbers. When x is 1, y is 1. When x is negative 1, the absolute value of negative 1 is 1, y is 1. When x is negative 2, y is 2. Reflect it. Here's our parent function. Y equals the absolute value of x. What's our h value? In other words, what is our shift? Here's our function, y equals absolute value of x minus 5. Well, our h value here is 5 because we are going to be moving. Now think about what the minus 5 means. It's the opposite of what you think because it's in absolute value. So that means it's going to go right 5 units. So I'm going to take all these points and I'm going to move them right 5. 0, 0 moves to 1, 2, 3, 4, to 5, 0. This point 1, 1 moves over 5, 1, 2, 3, 4, 5, and now becomes 6, 1. Basically, we add 5 values to our x. This x value is at negative 1, so I'm going to go 5, 1, 2, 3, 4, 5. And there, quickly, is the new function. Y equals absolute value of x minus 5. All right, and lastly, the graph here is a translation of y equals just the negative absolute value of x. Write an equation for the graph you see. Let's think about what this graph looks like. What does the negative do to it? Oh yeah, that flips it upside down. Or you can say flips over the x-axis. So here's the basic function, 0, 0, and goes down. How did this graph here change from it? Well, this graph moved 1, 2, 3 units to the left. 3 to the left. How do we represent that in equation? Hopefully you're thinking left is always seen inside absolute value. So it would be y equals, this graph is still flipped upside down, so we still have the opposite on the outside. And then to represent left 3 units, we have x plus 3. And that's it. You guys enjoy the rest of your day. Your homework is 2-6 from the calendar.